What is up? Welcome back to another Unreal Engine course, and this time we have a really cool game. And of course, before we start creating the game, I'm going to show you what we are going to create. But before we do that, one thing that I saw that is popular now among a lot of YouTubers is creating a video called "My Channel is Dying, Help Me." While I might create that because, I don't know, it seems like to be a trend, but for now, I'm just gonna ask you to like the video, comment, share, and subscribe to the channel because that helps the algorithm so this channel can grow, other people can see the video. So thank you for that. Now, let's just see the game that we're going to create. So if I hit the play button, we have a nice ball. We have a nice glowy effect. We can move the ball left and right. We can jump with the ball. So this laser over here is going to kill us. Pay attention at the top left corner for our energy. Bam, is being drained, as you can see. We can interact with these cubes. So I can, like push it or drag it towards me like this. And I can jump from one wall to another like Spider-Man over here. And of course, we're going to learn how to do all of this. We do need to drag this other cube so that we can prevent these other lasers from killing us. And there you go. Now we can jump on the elevator, click on the E button to interact. And when we jump off the elevator, it goes down. And no, now we cannot reach the top. What we can do? Well, we can jump and interact with this cube. There you go. So we can do that as well. Bam, there you go. And we can jump over here and voila, we reach the top. Of course, this project, you will have assignments in it. That's the beauty of it. So I will give you assignments to finish the game and you can add new features because this serves like a template that you can use to build upon. So you can add new features and that way you can learn and so on and so forth. Now, even though this looks like some simple game, believe me, you're going to learn a lot of cool things because a lot of interesting things went into creating this project. So again, just go through it. You will have assignments to finish it because I will show you how you can rearrange these rocks to create other levels, to add new features, more obstacles, so on and so forth. Again, while my channel is still not dying and I'm not asking for help, just share the video, like it, subscribe, and comment below. It helps the algorithm so this channel can grow. So yeah, we're all a community over here, so be part of a community, like share it, so other people can benefit and you help me as well, so it's a win-win situation. Anyways, thank you. Thank you for watching this video and stay out of jail, I guess, man, because you cannot watch this video if you're in jail. Take care and enjoy the rest of the tutorial. So now that we saw the game that we're going to create, let us actually create the game. So over here, I have the Unreal Engine project browser. You know what it is. So we're going to click here on the games and then click on next over here. We want a blank project. From here, click on next. Blueprint is fine. We don't need the starter content. So you can either do it with or without, but essentially we don't need it. Everything over here can be as is. Now over here, as you already know, is where you're going to store the project. So make sure that you, set that to your desired location. And over here is the name of your project. So we are going to call it Platformer. There you go. And I'm going to click on create the project and voila, we are going to wait probably a gazillion years. And I think that I will need to cut out the video. So yeah, see you when this finishes. And finally, we are here. It didn't take that long, but I still had to cut it out because you will probably be mad and be like, oh, blah, blah, blah. And I'm not going to go further into that. Just kidding. But anyways, the next step for us is to click here on the content, right click that is, and show in Explorer. There you go. So this is where we are going to put the assets, and the assets are right here. So these are the assets. You can download them. Link will be below this video. So just, scroll down below the video and you will see a link where you can download the assets. And what you're going to do is copy all of these. So copy all of the assets, everything that you see in this asset folder. And over here, again, right click here on the content, show in Explorer, and it will open this bad boy for you. Right click and paste the assets. So when you paste the assets, we are good to go. Now, when we go here in the maps and click on the example map, voila, this is our map. Now, again, these are all, as you can see, separate items that you can put together in order to create the level. And what I'm also going to do is here inside of the outliner, so world outliner, which is on the right, I am going to right click over here and create a folder, and it's going to be level parts, or however you're going to call them, and I'm going to select all these rocks, and I am going to put them inside of the level parts folder, just so that we can organize them a little bit and we don't have, everything clustered inside of the world outliner. Anyways, what's good about this is that you can always, you can move these things around to create new levels, yada, yada, yada. It serves like a template and stuff like that. So, for the assignments that I will give you later on to create new levels, you can do that on your own. So basically that's that. Anyways, the next step for us is to go and create our ball player. So let's go over here in the blueprints, which is currently empty. I'm going to right click and we are going to create a blueprint class, and this class is going to inherit from the character. Now, as you can see here, characters are pawns that have a mesh, blah, 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 blah. Click on that, and this is going to be BP underscore player ball. So player underscore ball, or you can put that you can put that all together. It's up to you, it's not important, and I don't care, I don't care what you do. Okay, it's your life, you can do whatever you want. But anyways, just kidding. What you need to do, or what we are going to do now, is that we are going to add a mesh and all the good stuff. Now, first things first, we are going to attach or add a static, or actually, a static mesh component. So let's go over here, click on add component, and filter for static mesh component. Here it is. This is the bad boy. As you can see, this is the skeletal mesh. We don't want that. We want this one, static mesh component. Now for the static mesh, click here, as you can see where it says the static mesh, click there and filter for the ball. So click ball and SM ball. Here it is. So click on that one, and there you go. This is our ball. It's, very funny. Now over here for the elements, we are going to search for the ball element. So click here, ball, filter for the ball, and there you go. It looks like a golf ball, It looks like a golf ball. So we're going to say it's a golf ball. Anyways, what we are also going to do is we are going to scale it. So over here in the transform for the scale, click on the lock icon, and we are going to say 1.5 for the scale to rescale the ball so it gets a little bit, larger. Also for our capsule component, what we are going to do over here is the half height, and the radius are going to be 75 for the half height. Radius is going to be also 75. So as you can see now, the whole ball is covered in the radius of the capsule component. Make sure that you compile and save that. What I am also going to do is I'm going to attach a spring arm. So click here on add component and filter for the spring arm. Now, if you don't know what is a spring arm, basically it's a holder for the camera. So you can think of a spring arm as a holder for the camera. What we are going to do for the spring arm is over here for the rotation on the Z axis, we are going to say -90. There you go. And we are also going to set the target arm length. So this over here in the camera, it's currently at 300. We're going to set it at 1536, so 1536, which is going to make that a little bit further away from the ball. There you go. When it comes to the target offset for the Z-axis, we are going to set that at 300. There you go. And basically, as you can see, it's right over here, like in a diagonal way with an angle. It's looking at that ball. So basically that's that. Do collision test over here. We don't need this. So if true, do a collision test using probe channel, probe size. We don't need this. We don't need this. So compile and save that. And the next step for us is selecting the spring arm and attaching the camera. So click on the camera, and there you go. So now we have the camera on it. When it comes to the camera, we are basically not going to touch anything. We don't need to touch anything because we have everything set up within the spring arm. Now make sure that you compile and save that. If I were to go over here in the example map and hit on play button, and over here, just 1 second, we do have, because I prepared this project and some of the things that we do need to delete, what we need to do is go here while you're in the example map level, click on you see over here where it says blueprints, click on the drop down list and click here open level blueprint. When you click on that, just delete these two nodes. So just delete these two, compile and save that. This is later on for creating the UI for the game. So when we have our UI, we will have this over here or somewhere else. It's not important, but that is for the UI. If I hit the play button now, everything is cool. But you see this over here, we don't have our ball, we don't have anything. So what we need to do is go back here in the content browser inside of the blueprints and right click and create a blueprint class. And from here, from all classes in the search, we are going to filter for game mode. And we want this one, game mode. So make sure that you select the game mode, click on select, and this is going to be BP underscore platformer underscore game mode. So this is our platformer game mode. We only need it for one reason, and that is to go inside of the project settings and click here maps and modes. And over here at the top where it says default game mode, we're not going to set the game mode base. Instead, we're going to say the platformer game mode, the one that we have just created, which now enables us to edit the default pawn class, which is actually the player. So from the default pawn class, we're going to select the BP player ball, which means now when we go here in our example map, let me just close the example map blueprint. Over here, as you can see, I have already prepared from this level. This is the player start, or where the player is going to be spawned when we run our game. So if I hit play now, there you go. We have the ball, and this is because we created the game mode base and we attached it over here, and we set the player ball to be the default pawn class. And now when we, run the game, it is being spawned. Moving forward, let us go back inside of our player ball. And what we are going to do first is create the variables that we need. So the first variable is going to be our ball material instance like this. Now I am going to just declare all of these, then I'm going to set the types and whatnot. Next we have the move direction. Next, we are going to have over here flat velocity. And what did I type over here? So it's flat velocity. There you go. Click on the plus. And again, here we have the current speed. Moving forward, we have the rotation amount. So rotation amount. Moving forward, we have the ball rotation rate. Moving forward, we have the power. We have the energy, so energy, and is dead. And last but not least, we're going to have the HUD reference. So click here, compile and save. And what we are going to do? Well, first things first, we are going to set the ball material instance. Click on, you can either click here, so you can either click here on this little icon, the red one, because currently all of these variables are booleans. And you can either click there, where I'm currently pointing with this arrow, or you can click on here, variable type, which is in the details tab on the right side. And from there, you can click here on the search, and you're going to search for material, and you want a dynamic material instance. Let me just find it over here. Actually, is it dynamic or just material? Let me just see over here. So it's dynamic material. Yeah, here it is. Material instance dynamic. This is what we want. And you're going to click on this object reference. This is what we need. So material instance dynamic. Move direction is going to be a vector. So click on the button to choose a variable type, and move direction is going to be a vector. Flat velocity is also going to be a vector. So click on the button to change the type of the variable. The current speed is going to be a float. So click on the button and select float. The rotation amount, same, is going to be a float. So click on there. The ball rotation rate is also going to be a float. But for the ball rotation rate, we are going to set the default value. So the default value for the ball rotation rate is going to be 0.75. And you can set the value over here where I have just drawn. Now, moving forward, we are going to have our power and energy. Both of these are going to be floats. So float here, energy is also a float. Make sure that you compile and save that. And over here, the value for these both are going to be 100. So 100 for the energy, 100 for the power. Is going to be a boolean, and we're going to leave it as is. Here for the energy and power, make them publicly available, and also for our puzzle mode. So we have one more variable, which is going to be our puzzle mode, and I am going to move it over here and put it right directly below the material instance. So let me just change the order, even though the order doesn't matter, but hey. So here I'm going to say puzzle mode. There you go. Click on the button over here, and we are going to set this to be a Boolean, compile, and save this bad boy. And also the puzzle mode, just set it over here to be a public one. Now, this is for the variables that we are going to use. Moving forward, what we are going to do. We are going to first create our event. So I can remove this from here. We will need this later on. But over here, right click, and for the node, we are going to search for a custom event. Custom event is the one that we created. It's not already defined. We are going to define it right now. So I'm going to call this bad boy enable disable input, and this is going to allow us to either enable and disable the input. Now, one thing, when you click on this over here, you can have these inputs, which are basically parameters. So I can click on over here for the plus button and add a new parameter, and over here the parameter is going to be a Boolean, and the name is going to be enable. So there you go. And now we have a Boolean parameter over here. So what's going to happen here is that we are going to go in a branch, and the branch is an if-else statement. And the condition that we are going to test is this enable. So enable is the condition that we're going to test. It's either true or false. If it's true, we're going to enable the input. But before that, we are going to get the player controller, because the player controller is the one who can enable and disable the input. So over here, I can say enable input, like this, and right click over here, I can say disable input. Now this is going to enable and disable the input on the player controller, which means it will disable the input on our ball. There you go. So if it's true, we are going to enable the input, and I'm going to click on this and I'm going to position it like this. And if it's false, we are going to disable the input, because the parameter is enable. If enable is true, then we're going to enable the input. If it's false, we are going to disable the input. Pretty straightforward. Here I'm going to create a comment section. I'm going to call this bad boy enable / disable input. And if you didn't see how I created a comment section, basically what you need to do is just, hover or select with your mouse like this by dragging your left mouse. Select all the nodes that you want to group in a comment, then right click and go over here, create comment from section. And of course you can select this comment, you can delete it and it can go away. So if I select it now and hit delete, it will be deleted and go away. Over here, everything is straightforward. I don't think there is no extra explanation for this, or if there is, just, let me know in the comment below the video. Anyways, moving forward, we want another custom event. So let's go over here and right click, and we are going to filter for custom event. And we're going to add here a custom event, and we are going to call this one change ball material instance. So the name of this bad boy is going to be, just double click it over here again. Okay, here it is. Change ball material instance. There you go. Now this, actually, excuse me, it's change ball material color, not instance, color. So change ball material color. Now this bad boy has two parameters. Click on him and inputs, click plus 2 times. The first one is going to be the param name. So here we're going to say param name, and the type over here is actually going to be the name. So name is going to be the parameter. And over here, we are going to have a value float. So here we're going to say value, and there you go. So compile and save that. Again, as you can see, we have two parameters. One is the name and other is the value. What we are going to do is we are going to get the ball material instance. So we are going to get it, which is the one over here that we have. As you can see, here is the bad boy. What we are going to do now, we are going to drag from here a node, and we're going to say set scalar param value. Basically, this is going to change the value of the parameter. So over here, we're going to plug this in. So this goes over here. Next, we're going to plug in the parameter name over here, and the value will be plugged over here. And after that, we are going to get the ball mesh. So here we have the static mesh, and I need to change the name to the ball mesh. I mean, it's not important, but for our references, it is better to know. So this is a ball mesh, and we are going to say over here set material. There you go, not this. So from here, set material, and we want this one. So set material, there you go. plug this in over here. This goes over here. And last but not least, we want the material, which is the ball material instance. So here, get the ball material instance and plug it in. And there you go. Compile and save that. Now, what I'm going to do is select this. And again, right click and create a comment from section. There's going to be change ball material color, and make sure that you compile and save this. What is this essentially? What is this going to do? Well, basically, if I go over here and select the ball material, and you see here we have the ball material. If I click on it, this is that material. And let me just open it. So over here is the material. Now, I'm not going to go into this because this is a separate topic on its own, you know, dragging these materials, creating them with the nodes and whatnot. But over here, you have some parameters like power, like is active, and so on and so forth that control certain aspects of that material. As you can see, we then have the divide, then put it in the lerp and the multiply. And basically, as I said, this is a separate topic on its own. I will probably create a separate video just talking about how to create materials, how to do this and that with them. But essentially, what you need to know for this tutorial is that these parameters like power, is active, and so on and so forth, they control the colors of this material. So over here now, when we call this change ball material color, the parameter value is going to be one of these parameters, such as power, such as is active. So we're going to put that in the name over here. And the value is going to be, well, basically the value 1, 2, 3, it doesn't matter, you know, but the value of the number. Now, what we need to do in order to make this work is go over here in the begin play, and I'm going to move a little bit up over here. The first thing that we need to do is we need to get the material of the from the ball. So here from the event begin play, we're going to drag a node that we're going to call set ball material instance. Oh, actually, excuse me, first we need to create that. So let me just get the ball mesh first, get the ball mesh, and from here, get the material. So get the ball mesh first, and then get the ball material from the mesh. And from the mesh, we are going to create dynamic material instance. There you go. And we're going to plug this in over here. Actually, let me just do it like this. Create dynamic material instance. There you go. And the target is going to be capsule mesh, ball mesh. Let me just take a look at this. What is this over here? So it's not giving me, the target is primitive component. Kismet library. Let me just go over here. Create dynamic material. We want the one from the, well, all of these are from Kismet. No, we want the first one. Create dynamic material instance. This is the one that we want. So you can get confused sometimes with these because, as you can see, create dynamic material instance. You see, we have, you know, a couple of these functions. So we want the first one, create dynamic material instance, and we want to plug in the parent over here, and it goes right there. So the next part, and we can move this closer because I'm going to create a comment from this. The next part is to set the ball material instance. There you go. And we want to set it to this return value that we have over here. See, returns value material instance dynamic object reference. So we can set that to this over here. Now I'm going to select these, and I'm going to right click and create a comment section. And what's going to happen here, first I'm going to say first set the material instance, the material instance. There you go. And we can move this from here. So you can move the begin play a little bit outside. It's not important, but just so. So something like this. There you go. Maybe a little bit up because later on we are going to plug things here in the tick event. So we got the material instance. What is the next step? The next step over here is to first enable disable input. So we are going to say enable disable input. And over here we have the parameter. We're going to leave it false. As you can see or know already, if it's false, we're going to disable the input. So we're not going to allow the character to move. So disable the input. After that, we're going to say change ball material color. The parameter name that we are going to pass is going to be is active. And notice here, is active, capital I, capital A. The value over here, or the name, that we pass over here as a parameter needs to match up with the name over here. As you can see, this is the name of that isActive. So isActive, you can click on it and you can copy the name, and you can then go back over here and paste it just to be sure, like that. The value is going to be 0. So we're going to leave the value at 0. And now we are going to delay. So we're going to call delay over here, and we are going to delay for 0.5 seconds. So half a second we are going to delay. And after that, copy this and paste it. And again, we're going to call change material color for isActive, but this time we are going to set the value to be equal to 1 and compile and save that. So let me just go back, compile and save that. There you go. I don't know if I didn't test it like this, but let me just try it out to see if this will work. Yeah, you see? So yeah, there you go. As you can see, of course, we are going to change another color. So we're going to change another color, but for that, we also need to create a timeline. So don't worry about that. We will do that in a moment. But as you can see already, we are changing the color. So first things first, and let me just stop this. First things first, we are setting the value to 0, waiting half a second, and then setting the value back to 1. As you can see now, how the color goes, as you can see, to the red color. So this is essentially what a small effect, not important for the game, but it gives a little bit crispy effect to the game, like, you know, it makes it look a little bit better. Going back inside of the player ball blueprint, next we need to create a timeline. So in order to create a timeline, we simply right click and simply type timeline like this, and here it is. At the bottom, add timeline, and we're going to call it ball activation timeline. And what is a timeline basically? Well, first we're going to drag a node over here to play, and a timeline allows, as you can see over here, timeline node allows values to be keyframed over time. How does that work? We'll double click on the timeline over here. And as you can see, we have values. So you have a float value, you have a vector value, you have a color track, you have an event track. We are going to click on the float track. And for the float track, you can, give it a name, whichever name you want. I don't know, value, simply type value. It's not important, or float track or whatever. We also are going to set the length over here to 1. So we're going to have a 1 length, and you can right click. So let me just compile and save that. So you can right click and you can click add keyframe, and you can click on this keyframe. And for the time over here, we're going to set it at 0 and value is 0. Right click and add another keyframe, and the value for this keyframe is going to be 1, 1. So basically the time, so when you click on it, the time is going to be 1, the value is going to be 1. This basically means it will go, or this float will go from 0 to 1 in the time of 1. This is basically what is a timeline. So the value of this float will go from 0 to 1 in length is 1 second basically. So this is what we are doing over here. So if we go back over here in this time graph, from the update, and what does this update in the timeline? Basically the time it will take for that float to go from the specified value, which is 0, to the goal value, which is 1. So while that is happening, this update will be called. And when that happens, from here, we're going to say change ball material color. There you go. So change ball material color. Now, the material color is going to be, from here, I'm going to take the power. So get the power. And we're going to lerp. So I'm going to right click and I'm going to say lerp. And we want the lerp to be from a float. So not vector. So power. Let me just see over here. Lerp. Here it is. This is the one that we want. And I'm going to break it from here. Let me just move this a little bit over here so that it is more readable. So what's going to happen over here, this is going to lerp from A, which is 0, to the power. Value of the power is 100. If you remember over here, if you select the power, we set the default value to be 100. Alpha over here is the time. So the time it will take to go from 0 to 100, and basically that time is going to be the value over here from the timeline. And we're going to set the return value over here. We're going to plug it in, and the parameter value is going to be the power. So the power, compile and save, if we go over here, we will see that we have a power parameter which is controlling the colors. Next, when we finished, so over here when we finish, we are going to call enable disable input. So over here when we finished, we're going to call this enable is going to be checked. So now we will be able to move. So compile and save that. Again, what is happening? So over here, everything that we did explain. So let me just select all of this, create a comment group, and over here for the comments, so double click it, we are going to say change the color of the ball. There you go. So compile and save this bad boy. So again, from here, we are getting the material instance. We explained this. From here, we're disabling the input. We explained that custom event that we have created. Change the ball material color. We have it over here. So it will change the ball material instance, the color name over here, and the parameter name over here actually, and it will set the default value. Then it will set that material to the ball meshes material. So over here, we are changing the material color for is active to 0, waiting half a second, then setting the material color for the is active parameter to 1, then calling a timeline that will create a value, this float value that will go from 0 to 1 in the time interval that we have already explained, and then we are going to use that in the lerp function, and lerp will slowly go from this value to this value over here in this time interval. So it will go from 0 to power, which is 100 in the alpha time, and then we are going to set that value for the power parameter. When everything finishes, we are going to enable the input. So compile and save that, and if we go back over here in our editor, and if I hit play, pay attention now. You see how the colors have changed. So again, stop and then click pause. Bam, it goes from no color to red color to green color. Now, of course, you can change or you can play with the parameter values to extend the length so that you can clearly or more clearly see if you don't see the changes of the color for some reason. So you can also extend the value of the time it takes to do that, but you know, I'm leaving up to you for you to experiment and yada, 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 basically. So yeah, let's move forward. The next thing that we are going to do is create the ball movement. And before we start to code that or blueprint that, we need to go here in our project settings. And for the input over here, we need to create our axis mappings and action mapping. So click on the plus button over here. So this one is going to be our first action mapping, and we're going to have a second one. And click on the plus button over here for the axis mappings. So first things first, over here for our action one, we're going to have jump. And for the jump, we are going to filter here in the search bar for the space bar. So space bar, when we press on our keyboard, we are going to jump. The next one over here, I'm going to call action. And action is going to be executed when we press the E button on our keyboard. So let me just find it over here. There you go. So when we press the E button on our keyboard, and we will be able to move the elevator upwards as we saw in the preview of this game. And we will be also able to move those boxes as well so that they can come closer to us and so on and so forth. This will happen when we press the E button. Now over here for our axes, we are going to say move right. This is going to be the name of the axes. And now over here, not pressing this plus button, but pressing this plus button to add another input. So basically, click here, and the first one is going to be keyboard or key code A, and the next one is going to be key code D. For the key code A, we're also going to add here minus. And there you go. So this basically means when we press the A or the D key, we will trigger this move right axis mappings. Now, what is this A and D? Basically moving left and right. -1 is for A because negative side, left side basically is the negative side. That's why we add here -1. So now we can go in our ball player blueprint, and right here below this change ball material color, we are going to create another custom event. So right click over here, custom event, and this one is going to be movement update or movement, however you want to call it. It's not that important, but it's important that you know what it is. So over here, we're going to go in a branch, which is an if-else statement. And basically, it will be true or false. And the condition over here is going to be our puzzle mode. So I'm going to plug it in over here. And if it's true, we are going to move our ball in one way. If it's false, we are going to move it another way. So first over here, I'm going to right click and we are going to say set move direction like this. And what's going to happen over here from the true, I'm going to drag it, and I'm going to click on this line for the node 2 times so that I can add another input over here so that I can, as you can see, I can visually set it or make it more clearer to read. Clearer now is a word. Anyways, now over here, we are going to say get move right. And from the move right, we are going to make a vector. So I'm going to say make vector. And that vector is going to go inside of the x-axis. And I'm going to plug it in over here. And this is basically, we can move this a little bit up just to make it a little bit more clear to read. And let me just move it a little bit down like this so that it doesn't come close to this and doesn't obscure it, yada, yada, yada. Anyways, the next thing, if it's false, I'm going to right click. And from here, again, we're going to say set move direction. Like this, and the false one will go inside over here, and I'm going to double click it again and move it down like this, and move this like this over here. So if it's false, we are going to calculate it like this. We are first going to get, and actually I can move it up here because we are going to calculate it over here. We're going to say get actor forward vector. Like this. So we're going to get the actor's forward vector, and we're also going to get the move right, get move right. And we are going to multiply these two. So we're going to say from here, multiply by float. So we're going to multiply this vector by this float. And from there, we are going to normalize this vector. So normalize. And from there, we are going to plug in this vector over here. And if I hover over, it will say for the normalize, if you don't know what it is, gets a normalized unit copy of the vector, ensuring it is safe to do so based on the length. Returns 0 vector if vector length is too small to safely normalize. Basically, what normalize will do, it will stabilize the vector, so to say. It will stabilize it, and it will make the movement a little bit smoother. That's the best how I can explain it in understandable terms. So after that, what we are going to do, let me just move this a little bit here, move this a little bit here like this. I mean, it's readable, so everything is readable. Next, what we are going to do is from here, we're going to say add movement input. And from there, I'm going to plug this in like this over here. So go from here, there you go. I'm going to double click this to create a new line over here and plug this one here as well. So there we go. So now both of these are connected to this one, and lastly this one leads to over here, which means basically both of these are leading the execution order to the add movement input. Now the last thing that we need to do is get the move direction. So we need to get it and we need to normalize it. So normalize. And now that we have normalized the move direction, we can plug it in over here, and there you go. So compile and save that. Basically, again, what we are doing based on the puzzle mode, if it's true, get the move right, make a vector out of it over here, which is basically going to create a vector with the value for the x that we have over here, which is either 1 or -1, because over here, you see, we have -1 or 1, and all other values are going to be 0. And then we're going to set that to the move direction. Over here, if it's false, then we're going to get the actor forward vector, then get the move right, multiply these two, and from there, normalize the vector and plug it into the move direction. And over here, then we're going to add that move direction normalized to the add movement input, which is going to move our ball or character. And I'm going to right click on this, create a comment from section, and this one is going to be move update. There you go, and you can compile and save this. Now the last thing that we need to do in order to make this work, to run it, let me just move these comments or these sections over here and probably move this a little bit up over here, because now over here in the tick event is where we are going to call the movement update. There you go, because the tick event is called every frame. Basically, it's like update in Unity. So compile and save that, and it will call every frame this event, or you can think of it as a function as well, and it will execute all the code that we have just explained. So now we can go back over here in our example map, and if I hit the play button, and now you'll see that the ball is moving. Of course, we cannot jump and the ball is not rotating, so the next step will be to create that. But the ball, as you can see, can move left and it can move right as well. And we're moving left by pressing A key and moving right by pressing D key. In the case of, because this is a 2.5D platformer, we're moving forward and backwards. Backwards by pressing A, forward by pressing D, you get the point, yada, yada, yada. If something is not clear, make sure to ask in the comment below so that I can explain this before you proceed to create other things that we are going to do right now. Moving forward, the next step is to go back in our player ball, and now that we are moving, let us rotate the ball. And we're going to do that right below the movement update. So I'm going to right click over here and create another custom event. And over here, I'm going to rename this one to rotate ball or something like that, just so that you know that this is used for rotating the balls. And also you can think of these custom events something similar like a function. I already mentioned that, because you can basically create them like this. You can call them over here. Of course we can, as you can see over here, we have this place a new node, but basically this can allow us to have a delegate on this event, but I'm not going to go into that right now. We will do that in another video. Anyways, what we are going to do from the rotate ball. First thing, from here, I'm going to drag a node and I'm going to set the flat velocity. And what we are going to set in the flat velocity? Well, first over here, I'm going to say get the velocity. So velocity, and we are going to get that from here. Target is the actor. Then we are going to break this vector into pieces so that we can have separate X, Y, and Z. And from there, we are going to make a vector. So from here, I'm going to say make vector, which will create a new vector that will allow us to plug in X, Y, and Z. So we're going to plug in the X, we're going to plug in the Y, we're not going to plug in the Z because we are not moving. So we're not moving the ball like this, we're moving it forward and backwards. So we're not going to plug in the Z, and we are going to plug this bad boy over here. So this is, let me just move these a little bit, and this one over here, so that we have, you know, like a better visual representation of the node, because these nodes can get a little bit tricky if you have too much of these. They can get messy and so on and so forth. Same as like spaghetti code, you can have spaghetti nodes, so you need to be careful about that. Anyways, moving forward from here, we're going to set the current speed. And for the current speed, we are going to set the length of this vector. So length, and from here, we are going to say vector length. Here it is. So select the vector length and plug it. I almost said pug it. Plug it in over here. As you can see, the vector length is basically this. Think of it as a vector. Vector is like A, X, Y, and Z. So X, Y, and Z. The length of the vector is, we will use the length of this line, length of this line, and length of this line. So it will, you know, like form a single line out of these three. So that is the length of the vector. So let me just compile and save this. So now that we have the current speed, we are going to go in a branch. So from here, create a branch, which we already know is an if-else statement. And we're going to test the current speed. So we're going to get it, and we are going to test if the current speed is not equal to. So it's not equal to. Notice I'm using the exclamation mark, and over here, it will make it not equal to, and we are testing it if it's not equal to 0, basically meaning that we are actually moving. So if it's not equal to 0, that means we are moving. And if that is the case, so if it's true, if it's false, we're not going to do anything. But if it's true, then we are going to set the rotation amount. And the rotation amount is going to be calculated like this. First, we're going to get the flat velocity. So get flat velocity that we set over here. So this is our flat velocity. Then from the flat velocity, we are going to get the vector length. So it's length, and I have issues spelling length apparently. So get the vector length from the flat velocity. And after that, we are going to divide that by a float. So over here, divided by a float. And what is that float? Well, the float is going to be the ball rotation rate. So ball rotation rate. So get the ball rotation rate. We know that we set the ball rotation rate over here to be 0.75, excuse me. So there you go. Now we are also going to get the pi. So simply type pi, and I believe it's in the Kismet library. So let me just find it over here, not pinned, debug. Sometimes it's hard to find things that you need. So collision, not collision. Where is it? Here it is, get pi, here it is. So returns the value of pi, and for the pi, we're going to multiply that, so multiply with the float, and the float is going to be the ball rotation rate. And from there, we are going to plug this into over here. Now, the next step that we are going to do is from here, we are going to go and multiply this. So multiply with a float, and the float that we're going to multiply is going to be get world delta seconds, and we're going to plug this in bad boy over here. And moving from there, we are going to add that. So add a float, and not like here, break the link, but here, add the float, and over here, get the rotation amount, plug it in over here, and plug this in over here. Now, of course, we are not done. We have still too many things to do. I mean, too many things, just a couple of things, but going back over here. Now, this is one of the things that I want to talk about. Now, to be completely honest, going into detail how this works and what this is, I have no idea. But, you know, if you search online how to rotate a character, how to rotate a pawn, how to calculations to do that, you will find many different solutions. And you just plug in, sometimes I just plug in the solution and it works. This is just to show you that, you know, you don't have to know everything. I don't know behind the scenes how this calculation works. This is some, I'm not going to say complex math, but if you are into math a little bit more, you'll probably understand this, how or why we are using, or how we are using the vector length of the flat velocity, dividing that by the p multiplied with the ball rotation rate, and then multiplying that with the world delta seconds. This is everything to smooth things out. We can basically rotate the ball by just using get world delta seconds, multiplying that with the ball rotation rate. And it will work. You will probably be able to rotate the ball just by using that. So multiplying the get world delta seconds with the ball rotation rate and adding that to the rotation amount. And that will turn out just fine. But these extra calculations are just to smooth things out. But as I said, like, the math that goes behind this, I don't know completely. So just to be honest, so we are going to leave it like here. If somebody knows, he will explain in more depth. But this is just to show you that you don't need to know every single thing and every single aspect about game development in order for you to be a game developer. So you can, you know, just find some solutions online. If they work for you, they work. Great. Then you can just proceed, you know, further in your game. So what we are going to do next is we are going to take the ball mesh, and from the ball mesh, we're going to say set world rotation like this, and move this a little bit here and plug this in over here. So what's going to happen here, or the rotation that we are going to use, is we are going to get the flat velocity, get flat velocity, and from it, we are going to make a rotation from its x. So basically from the x-axis of the flat velocity, and sometimes, I don't know why it's a but anyways, so we are going to get from the flat velocity or create a rotation from its x-axis, and from there we are going to get the right vector because we are rotating forward. So we are rotating in this direction and in this direction. So that's why we're getting the right vector. And from there, we are going to create a rotator from axis and angle. So we are going to create, you see, creates a rotation from on this, and this is probably a how's it called, misspelling or mistype or type or whatever. Create a rotation from this axis and supplied angle in degrees. So the axis is the right vector from the x rotation from the flat velocity, and the angle is going to be the rotation amount. So get the rotation amount, and we are going to plug this into over here, compile and save that. Now let me just take all of this, right click, create a comment, rotate the ball like this, compile and save, and we can go over here and call it rotate ball so that we don't forget to do that. So we will need to call it here in the tick in order to test it out. If we don't do that, then it will not work. But going back over here, how we are getting the flat velocity is pretty clear. We're getting the velocity, as you can see, returns the velocity in centimeters, unreal unit seconds, blah, blah, blah. Basically, what is velocity? Velocity is speed over time. So the speed over time is how much the velocity is. So depending on the speed over the time, that's the velocity. And we're getting the velocity, breaking the vector of the velocity, getting the x and the y, and plugging that into flat velocity. This is pretty clear how we're getting that. We're getting from the flat velocity's vector length the current speed, and then from there, if the speed is not equal to null, because if we are not moving, the length of this flat velocity will be 0. And then we will not go inside of this branch and we will not rotate the ball. But if we are moving, then the vector length will be greater than 0. So from there, we did all of this here, as I already said, but probably, I didn't test it out, but I'm pretty sure that you can just rotate the ball by using get world delta seconds, multiplying that with the ball rotation rate and adding that to the rotation amount. You can try it out. And then from here, we are getting, again, from the flat velocity, we are getting creating a rotation from its x-axis and getting the right vector from there and creating a rotator or a rotation from that angle and that axis and plugging that into our rotation, set world rotation for the ball. Which means that we can basically go now over here and I can hit the play button and you will see now that if we move, you see how the ball is rotating. And notice how the ball is rotating only, you see when we go left, it is rotating backwards. If we go forward, it is rotating forward. So that is why we're using that get right vector, this right over here, get right vector. That's why we're using that, because we are rotating here in this direction and here in this direction. We are not rotating up or down or like this and like this. So again, if I run it, you will see now, pay attention, the ball is rotating. Moving forward, now we are going to create the jump for our ball because, well, we cannot progress in our level without it. So over here, right below the rotate ball, I am going to right click and we are going to get the jump, which is the input action. Here it is, input action jump. Now what we are going to do is when we press it, so over here I'm going to go in a branch, and what I'm going to test here in this condition is if we are falling, and we're going to get that from the character movement. So here is the character movement component over here at the top. It can detect if we are falling or not, which is the beauty. So from here we can say is falling. Let me just get it. Here it is. And I can plug it in over here. So if we are not falling, so if that is false, we are going to say jump. Simple as that. So there you go. Compile and save that. So again, the character movement component has some built-in features. It can jump, as you can see over here, target is character. It can jump on its own. It can also detect if we are falling down from the sky or basically falling down from the air. So we can use that from the character movement if we are falling. So if that is false, then we can jump. And we can test this out right away. We can go back over here. We can hit the play button. We can move. As you can see, now I can jump. Pay attention. You see? Bam, bam. We can jump. But, well, as you can see, the ball is not jumping that high. What we need to do is select the character movement and change some things over here, such as the gravity scale, for example. We're going to set that to 3.5. We are also going to set over here max step height. We're going to leave that. So walkable floor angle, we can leave that. We can set it 45 just to a random number. Maximum walk speed, I'm going to set that to 800 instead of 600. I'm also going to check this checkbox, can walk off ledges when crouching, which basically means that we can walk off ledges. Also over here, ball or jump Z velocity over here, it's at 420. I'm going to set that to 1,800. And over here, air control, we're going to set that to 1. So if you hover over when falling, amount of ladder movement control available to the character. 0, no control, 1, full control at max speed. So basically, we're giving full control to the character of the ball when he is falling. Also over here at the bottom for the maximum custom movement speed, I'm going to set that to 800. Basically, all these things are self-explanatory. So maximum movement speed, custom movement speed, basically how maximally the speed can be by which we are moving. Over here, for the air control, we already explained that. Jump Z velocity, initial velocity. So basically, on the Z, when we jump, how high that velocity is. Can walk off ledges when crouching. We already explained that. So on and so forth, yada, yada, yada. We don't have to explain all of that because, as I said, they're self-explanatory. So now we can go back over here in our game and hit the play button. And when we jump now, the ball is jumping higher, as you can see. And everything seems perfectly fine, and it is. Except when we get over here to this edge, we cannot bounce off of it. And we saw that when we jump on the edge or on the ledge over here, that we are able to jump from another ledge to another ledge, as you saw in the preview, from here to here to here to here, so on and so forth, but we cannot do that. How can we actually do that? Well, for that, we need to create something called a line trace by channel. So we need to go back over here. And from the true, meaning if we are falling, which means we are already in the air, we have jumped. So if that is true, we are going to say line trace by channel. There you go. And I'm going to move this a little bit over here because we have some calculations to do. The line trace by channel will trace a line from the start till the end, and it will give us a hit if we hit something. So from where to where we are going to trace that line. First things first, we are going to get the actor forward vector. So over here, right click, get actor forward vector. There you go. And I think I need to move this a little bit further over here because we will have some calculations. So over here. So what we are going to do now is from the actor forward vector, we need to do some calculations. So over here, we're going to multiply him. So multiply him with a float. And what float is that going to be? Well, first, let me just set this like this over here. Now I am going to get the capsule component. So getting the capsule component, and from the capsule component, I'm going to get the scaled sphere radius, or get scaled capsule, scaled capsule radius. Why did I say sphere? Because this is a capsule. This will return the capsule radius scaled by the component scale. So basically the scale of the radius, or capsule radius, is 75. We are going to scale it by the radius, and the radius is basically 1. So that is what we are, component scale, which is basically the scale of the component, which is 1. So after that, we are going to say from here, plus float, and we are going to add to it 10. So the value of 10. And this is the value that we are going to plug in over here to multiply with the vector, with the actor forward vector. Because now, let me just move these a little bit down. Here, I can get so I can say get actor location. And what we need to do is from here, we need to subtract. So we need to say minus vector. And we are subtracting it from here, and the line trace can go over here. And this is the start of our line trace. There you go. Now, where is going to be the end of our line trace? Well, from here, again, I'm going to multiply this with a float. But again, let me just click on it over here. Something like this can do. I'm going to move this bad boy over here. Again, we need to get the capsule component. Here you go. And get scaled capsule radius again. So move it over here. And again, we're going to add to it 10. So plug this in over here. I'm basically just copy and pasting this. You can select it. You can Control C, Command C on Mac, and Control V, Command V on Mac. And after that, we are going to